Well, good morning, everyone, and thanks for joining this morning at Will It Blend 2023. I hope everyone's been having a great 3D experience world thus far. You know, the last day, always interesting, seeing what kind of lessons you're able to learn, what kind of tips and tricks you're able to pick up, and I hope from this section that everyone's able to take something home with them. I'm going to have a pretty fast pace today, so if you do have any questions, happy to talk afterwards, but just for the sake of the flow of the presentation, just ask you to hold those to the end. And with that, we'll get started. So Will It Blend is all about advanced filleting and blending strategies in SOLIDWORKS. You know, we can rely on the fillet tool to get us a lot of the geometry that we need, but sometimes we need to go in and manually create more geometry with some of the other tools in SOLIDWORKS to be able to get what our models actually need rather than what the software gives us. My name is Andrew Lowe. I'm the design director with Cortex Design. I realized I've been using SOLIDWORKS for half of my life at this point, 18 years of SOLIDWORKS since 2005. Have been putting together some content previously on plastic part design, on surface modeling, and this is actually a new and improved version of my very first presentation back from 2014, also entitled Will It Blend, just minus the 2023. So just a quick blurb about Cortex Design, my employer who was graceful enough to sponsor this visit today. We're a full-service product design consultancy focused in the medtech space, industrial design, design engineering, and embedded systems development. We're certified under both ISO 9001, ISO 1345, and just some of the samples of some of the products we've designed. This is a roadside drug and alcohol tester. We'll be looking at an example from this product later in the presentation. This is a disposable wearable device for nerve regeneration. This was a COVID-19 tester that we developed in the height of the pandemic. It did not go anywhere, but it was still very rewarding to be part of that process. This is a small, also disposable medical device, but significantly higher price point than the other device. It is used to detect certain infections in the abdominal cavity up to 24 hours before they actually happen. We've worked in the AR space, so this was a heads-up display for firefighters, a lot of interesting ethnography that went into some of the product decisions in this device. This was a box that went into a helicopter, so IP67, military shock and vibration, and we actually produced about 50 or 60 of these units on behalf of our customer. And this was a roller and heated vibrating product for certain kinds of exercise rehabilitation. And if you're wondering, yes, I did model the pattern in SOLIDWORKS. We won't get into it today. Maybe that's another conversation. So, fillet blend. What is the difference? The fillet is typically either an arc or spline-based transition, depending on some of the settings that you have in the program, that's used to round over edges. And when some of these fillets come together, you get interesting results. And when you do get an interesting result like this, you may need to go into your model and add a blend. And so a blend is the blue face here, and this was something that was created outside of the fillet tool. So when we're referring to these kind of fillets versus blends, fillets are typically what the fillet tool gives us, with exceptions, and blends are geometry that we've had to go in and manually create ourselves to be able to either get the functional or aesthetic requirements of our parts. And if we look at this example rotated a little bit, you're going to see that the only fillet-based transition almost has a pucker into the part. I don't think anyone would intend that to be the intended geometry, and the blend brings the geometry to where it needs to be. So why do we add fillets in our models? Well, for an industrial design point, cosmetic reasons. Rounded corners are a common element in many industrial designs. You know, rounded corners look nice. They're softer to hold in our hands. They're more comfortable. They're everywhere around us. They almost blend into the background. Interesting little note, and why I have this Apple iPhone example here, is that a lot of fillets on consumer level products aren't actually fillets. They're carefully sculpted radii, and we'll get into why that's the case just a touch later. Here's a mood board of multiple different products, mostly in the medical space, and they all feature rounded geometry, but some of this geometry could be created with the fillet tool, or in other situations, the geometry might have to be created manually, where we have the intersection of different fillet shapes. There's also engineering reasons of why we'd add fillets to the models, or Fillets can reduce stress concentration. They distribute loads over a broader area. They make parts more durable. Also for manufacturing, concave corners can aid in the CNC machining of parts, can also help with material flow and molding and cast parts. Radii are also used to eliminate sharp edges that could easily be damaged or could cause injury when the part's handled. And in the medical space, cleanability is a big concern. Concave corners can increase the ability for a surface to be wiped down, cleaned, or disinfected. Just a couple quick screenshots of why we might want to add fillets in our more engineered kind of parts rather than our more aesthetic, sculpted, industrial design type parts. We'll be looking at briefly at some examples from this part here, but some other examples of fillets in the real world and some of the transitions. We won't be getting into all of them. And also looking at some blends in the real world. So we have an example where a chamfer blends into a fillet. We have an example where all of the fillets in the second image are actually sculpted. They're not created with the fillet tool, and there was also some interesting geometry that had to be massaged in order to get correct parting splits for the different mold directions. And also just some blended kind of shapes where you have this very soft pebble-like example in the final image. Realize we got a couple duplicates. So I want to jump into fillet theory. This is how fillets work in SOLIDWORKS. They need somewhere to end. So in this example, I would like to apply a fillet to the red edge. I'm going to round that over. And everyone's done this before. We know the result we're going to get. But why are we getting that result? Well, the fillet tool is actually smart because in the background, it's able to extend faces and end these fillets. So if the fillet tool was less intelligent, it might do something like this example where it's the equivalent of just blasting a cut extrude through the model, that the fillet totally passes through the two conical shapes on the end, creates this undercut. This is maybe what you might get in the literal definition of adding a fillet, but it's not actually functional. It doesn't help us advance our part geometry. But the fillet tool is smart, and because it's smart, it's able to extend the faces in red and give the fillet somewhere to end. Likewise, if we were to go add a fillet to the intersection between the flat shape and the conical section, the fillet tool, if it wasn't able to extend faces, might give us something like this, where this fillet shape runs off the edge of the part. But once again, the fillet tool is smart, and it's able to extend that face to give you somewhere for the fillet to terminate. The fillet tool is also smart when you're adding different fillets onto each other. The fillet tool is able to taper existing fillets and provide a transition. And typically when we run into scenarios where fillets can't be created in SOLIDWORKS, 90% in my experience of these errors are caused by the inability of SOLIDWORKS to extend faces and properly end the fillet on the model. And so if we look into that kind of technique, how could we potentially add new faces or new ways for our fillets to end in our models? We can start looking at some ways of potentially working through these errors. Before we jump into working through those fillet errors, I'd like to touch on the concept of continuity and how it impacts the fillets that we're applying to models. So for those of you not familiar with the concept of continuity, I'd like to provide a quick thought exercise. If I was a limo driver, what would be a smoother ride for my passengers? If I'm driving the limo, I'm going to instantly take the wheel and whip it as hard as possible, hold it in one orientation, and instantly unwind the steering wheel like such. Or would it be a smoother ride for my passengers if I was to gently turn the steering wheel to the correct angle and then gently unwind the steering wheel? And this essentially is the concept of continuity and the connection between different faces in models. So a G0 or contact continuity condition is where we have two edges that touch each other, but they are not continuous. There is no smooth transition between them, and you can see the hard edge. Also, when looking at the curvature combs, which show the radius or the change in the radius along a curve or a surface, it can also show us a little bit more of what's happening with these transitions. So the G1 transition or the tangent transition is the classic fillet tool arc-based transitions. Here I have an arc section. I've sketched another arc between it. That arc has a different radius than the side faces, and then the second or third radius between the different faces, between this face, the fillet face, and the second face. If we look at the curvature combs, there is not a smooth transition. This is the equivalent of the limo driver cranking the steering wheel because the rate of change of this radius is constant. It has a constant curvature. If we look at the next level of continuity, or G2, we can see that the radius is changing along the length. The radius starts at a radius that matches the input surfaces and also ends at the input surfaces, but the radius is changing along its length. An arc can't define this, so we have to use a spline to define this. This example is the curvature continuous option in the fillet tool that is now available to us in SOLIDWORKS. A final level of relation is G3, and this is the smoothest level of continuity where the rate of acceleration is also smooth. So here we can see that there isn't that smooth transition, but on the G3 there is. This is the level of continuity that we see in very reflective sculpted parts, especially car bodies. That level of surface modeling is typically not done in SOLIDWORKS, and all of the transitions between different patches that are created in the CAD software need to have this G3 level connection. It is possible to do in SOLIDWORKS. We'll look at an example at the end of this presentation, but take it with a grain of salt. It is not particularly parametric, and you can get into a lot of unknown rebuild issues and be banging your head against the wall, but it does get you the smoothest possible geometry. So if you are looking for this kind of modeling, I would advise do it at the end of your creative or your design process where you potentially work with lower orders of continuity and then rebuild or resculpt a model for those higher levels of continuity. We can also look at the curvature display in SOLIDWORKS and see the difference between these transitions of tangent, curvature, and torsion. The tangent, there is no change in radius, and so that's why we see that constant green section. It's just showing one radius. Whereas in the curvature and the torsion examples, we do see a change in the radius as shown by the curvature display. But this also has an impact for the fillets that we're adding to our model, in that the higher order of curvature, the larger the fillet radius must be to visually look the same. And to illustrate this point, I'd like to jump into SOLIDWORKS. And so I have 4 different examples of continuity, G0, G1, G2, and G3. But if we look at the model edges between the different transitions, they're actually getting larger. So we might say that the G3 radius is larger than the G1 radius, but visually they all look very similar. And if we were to turn our model edges back on and grab a side view profile, these fillets are almost identical to each other. So we're talking very, very small differences in the geometry of these transitions, but they make a big difference in the quality of the reflection. If we look at the G1 reflection, I can see exactly where that fillet starts and stops because of that abrupt change in curvature. With the G2 example, that starts looking a little bit more seamless as that highlight starts blending into the other faces in the model, and likewise on the G3. So when we talked about that Apple iPhone, there are extremely carefully sculpted corners to be able to get that seamless style of transition. It's not just a box that had fillets applied to the corners. And so the higher the continuity, the larger our fillet needs to be. And the rule of thumb I've found here is about a 40% difference in going up level of continuity. So I'm just referring to this as R1, units are arbitrary, but if we had let's just say inches, a 1-inch fillet in a G1 condition, if I was using the curvature continuous fillet in SOLIDWORKS, I would need that to be about 1.4 inches to visually look the same. And if I was manually modeling these blends, because there isn't a G3 level fillet in SOLIDWORKS yet, I would need to effectively give an area for that spline of about 80% more than the 1-inch G1 example. So just something to note, the higher the order of continuity, the larger your fillets need to be to visually look the same. And at a certain point, we're just talking about the visual looks. When we're talking G2 and G3 continuity, we're less focused on the engineering applications. And overlaying these different examples, we can see that these fillets are essentially the same, but the start points are moving their way back along this transition. And so one by one, we see the abrupt change in curvature of the G1 connection, the slightly smoother transition of the G2, and finally the very smooth connection of the G3 with that comb starting at nothing and gracefully making its way up along the radius. So, fillet errors. We had talking about before, show of hands, who's seen this error message before? Probably everyone in the room, right? And so once again, the most likely cause of these errors is SOLIDWORKS not being able to properly terminate faces. And if we look at this a little bit further, jumping back into SOLIDWORKS, this part needs a rebuild on open. So I have this block of geometry, not entirely certain what it is, doesn't really matter, but I'd like to start applying some fillets to the model. Based on the design intent or the feature history, I might not have been able to actually go in and reorder the fillets in this model. Maybe I was stuck with this. Maybe this was imported geometry. So I'm going to add a 1/4 inch fillet to this edge. And I don't get the preview, not necessarily the best sign. I go to click OK, and I get the warning, the radius of the fillet is too large to fit the surrounding geometry. So it doesn't really know what to do of how to terminate itself as it comes to this point and as it wraps around this radius here. Also, show of hands, how many people in the room? 0.22. Oh, there's the preview. This is looking pretty good, right? Well, if I'm not putting in a dimension on it and it's in the block tolerance, does it really matter? I get my job done, I go home at the end of the day. Who's going to know other than me, especially when I step this out, right? That it wasn't a 1/4 inch fillet. So we're going to remove that fillet because we actually want to do the best possible job here. We want to make sure that it is that true 1/4 inch. And so I'm going to add some new faces to the model. And I did this very rapidly with a cut feature. So I just cut out that corner of the model. And, oh, there's a fillet. Let's check its size. Oh, there's the 1/4 inch. So he's able to add this by eliminating the corner that the fillet had issues working with. But now I have a notch in my model. How do I get rid of the notch? Well, we have a lovely tool called delete face. And delete face has several different iterations. You can just delete faces, and if in this case it would just turn the model into a surface body. Delete and patch most likely won't work in this iteration, but is an excellent tool for cleaning up sliver geometry. And then delete and fill actually is a combination of delete and a surface fill in the background. So it's going to replace these faces with a new type of face in my model by removing these faces and filling them with a new connection. I have the option of a tangent connection, which in this case I wanted because I wanted to have this smooth corner. But in some instances, I might not want to have tangent. And in this instance, I have my model edges set to phantoms, so tangent edges are dotted, solid edges are not. And we can see here that these edges are solid, they're non-tangent. And if we turn off this, it doesn't look great. It's probably not what we wanted. So just ensuring that when we're doing this final level of cleanup, that the tangent fill option is on. And now no one's going to be the wiser that I couldn't add my 1/4 inch fillet because of this tricky corner. I just removed the corner from the model and then cleaned it up with delete face. Likewise, the next little bit of fillet diagnosing could be what happens when we reorder some of the fillets. And this would be if you had access to the model history, that it wasn't too much work to try and move things around your feature tree. If you can do this, it's always potentially a little bit cleaner. And this speaks to the order that the fillets were applied in. So I'm applying this large fillet first, the 1/4 inch fillet that we had problems with before. And ultimately, what was giving me problems was this fillet here. And this fillet, for whatever reason, is 0.22 of an inch. And that 1/4 inch fillet had a problem trying to wrap around the smaller radius. As a rule of thumb, the smaller the fillet radius, the more likely you are to have it be able to add itself on top of other fillets. And so if you can find your way to be able to reorder that feature tree, it might be a little bit easier than having to cut out the corner. I still do have this kind of janky transition here, multiple different patches. And I can once again use delete face if I was so inclined to remove those extra faces, even though they were all tangent, and help clean up the corner of this model just a little bit. So running back through, once again, the reason this is happening, SOLIDWORKS not being able to extend our faces to give fillets somewhere to end. But regardless of what SOLIDWORKS says, you need that geometry. And so the fix here is give new faces for SOLIDWORKS to work at by identifying where the fillet might fail, cutting that away from the model, and then replacing it with the delete face. Once again, reordering or rearranging the fillet order can also be effective in solving some of these issues. So I want to jump back into SOLIDWORKS, take a look at another iteration of the fillet tool, and that is the face fillet tool. Show of hands, how many people familiar with face fillet compared to standard? All right, so most people here, but what face fillet is great at is being able to bridge faces in the model. We're over to metric now, so 10 millimeter fillet. I'd like to add it to this edge. It doesn't build. Why doesn't it build? Well, SOLIDWORKS is extending the wrong face on my model and not giving me what I want. So with the face fillet tool, I can ignore these two small little faces that are in the model that I've highlighted, and it builds around that transition. So face fillet's great where I can't actually add a fillet because of these faces, or I get a weird result. Alternatively, if I didn't want to do it with the, I don't know why I have a move face in here, I could also use the delete and patch iteration of delete face. This is great for cleaning up these little two faces. I select them, I delete them, I now have an edge, and I can apply that 10 millimeter radius back on because the faces that were erroneously ending my fillet have been eliminated. The final iteration of face fillet is examples where I don't necessarily have a clean edge to fillet. So if I went to try and add a radius to this edge, it doesn't really know how to apply this radius because it's bridging two different faces. This is a great use of face fillet because I can now specify the faces I'm filleting between rather than the edges I'm filleting between. I start getting my first portion of the fillet. Now I have a new face that I can add this portion, and then ultimately I add my transition. This is more of an example of how to show to get face fillet. If I wanted this to look great, I might be going into some more manual ways of being able to build this transition. Just a quick recap, face fillet is great for bridging over existing faces where required, or using delete face to clean things up, and then being able to specify faces that fillets are applied to because there isn't an option with the edge. So I want to start getting into some combinations of both filleting and blending in some real-world examples. The first example is fillet across the parting line. This fillet, once applied, it's pretty sloppy. I'd like a smoother transition. How might I go about getting a better intersection of these two different fillet faces? Well, the same premise of adding new faces to our model also applies, but instead of cutting away from our model, we're going to look at a alternative way, and this is honestly my preferred way of terminating fillets in models. I know they added the ability to end fillets at a certain iteration of SOLIDWORKS. I just find this technique works so much better, and that is the split technique. So split is used to cut a model into different, or halves, to split it. In this instance, I've converted the parting line in this plane, and I'm using this sketch with the split tool. So it'll always ask you for a template. You can't turn that off for some reason. So you just hit cancel. You don't actually need a template. I'm going to pick my sketch. I'm going to cut the part, and then it will cut the model in half. I can also use planes. I can use surface features. I can build more complicated trimming tools using surfacing or using different sketches or more complicated sketches to cut my part. It's a really powerful feature when you start getting into multi-body modeling because you're able to introduce new faces, but then combine your model back together. So once I split this at the parting line, when I add my fillet here, it's a lot smoother than it was before. And that was because these two different angles coming together introduced a little bit of waviness as it came to this intersection. So depending on the fidelity of the cast part or molded part that you're working on, this may be totally acceptable, and that this being the mismatch at the parting line. So these are both the same fillet radii, 1/4 inch and a 1/4 inch, but they don't quite line up at the parting line. I do need to put my two halves of the model back together, and I can do that with combine. Combine is grayed out. Oh, because I've already combined it. That's where it is. By being able to add this back together, and then I have a slightly cleaner transition. But what if I wanted to have a perfect parting line? I wanted to get rid of this sliver face. How might I go about that? And the alternative way of adding new faces to the model, and this should work once this gets suppressed, perfect. The alternative way of adding these to the model is extruding material into the model to add new faces. This works in the same way as split, but it might be a little bit more convenient depending on what exactly you were looking to do. So I was going to try to add another 1/4 inch fillet to this top edge, but this surface was manually created with a surface blend. The software probably doesn't know how to extend this intersection as this fillet kind of fades out to nothing in this instance. And so to work around that, I've added a little bit of material to the model, and now I have this nice new face that I can stop my fillet at. Now this fillet has no problem terminating. Likewise, the other fillets in the model, but how do I get rid of this block that's now in my model? I don't have a convenient set of faces that I can select to use the delete and fill tool. Well, that's where split line comes in. So what split line does is take sketches in models and project them onto edges and splits them. So if we were to, I now have this new edge, and this face has been better defined for being blended out of the model. Needed to add another split here. So I'm framing this transition, but unfortunately I can't use the delete face. So I have to do what delete face is doing in the background, and that is surface fill. So I'm going to delete these faces from the model, and we're only going into the surface realm very quickly for those of you who don't like the orange features, or I guess they're blue now. And the reason I need to do this is with the delete face option, it's either all contact or all tangent. With surface fill, I can actually pick between different edges and set different end conditions of contact or tangent. So in this case, because there is draft between the top and bottom halves of the part, they're not actually tangent to each other. I need to pick contact for these two transitions. And now I get a situation where my fillet seamlessly blends out of the model. I was able to clean up this corner. I was able to nicely transition this fillet into these other fillets and seamlessly blend them out. Likewise, for combining this back into the model, surface fill has a great technique of merge result, create solid. So just one surface feature in your tree, you get back to a solid at the end of the exercise. The final example I'd like to touch on in this part is a situation where the way that the part was modeled means that the edges don't naturally flow together. I need to create a transition between these two edges and this edge here, but they don't actually connect to each other. How do I go about doing that? Well, I'm going to add the majority of the fillets, and these fillets kind of sit on top of each other. But I now have this transition here. I could look to just put a very big, fillet. I'll just try and put the biggest possible fillet that blends. Oh, that's, okay, yep, just keep going up until it works. But sometimes this doesn't work, sometimes it doesn't build. This is probably close enough, but the more manual workaround is to use split line, create this nice new kind of area for this blend to live in, and then force these two dissimilar fillets to flow into each other with the delete face tool. And even though my edges didn't initially line up because of the way that the part was modeled, I was still able to get the intended model geometry that I needed to create. So running through some of this example, split is a great tool, introduces new faces to the model. We'll be using some other examples with it shortly. Combine is used to put our split models back together after adding our necessary fillets. When these edges kind of tangentially end, they don't come together cleanly, we can look to use a split or a block technique to add additional faces into the model. This allows us to add the fillet successfully. We frame out the area for the blend with the split line, as you can see here with the red surface edges, and surface fill to clean up the transition. Likewise, for these fillets that don't nicely blend into each other, delete and fill with the split line, great technique to be able to force these dissimilar fillets to flow into each other. So I want to touch on this technique, but for aesthetic considerations. In this example, I have two different fillet intersections. One looks better than the other. The one on the left, I can very clearly see where those different fillets are ending. In the example on the right, the fillets more seamlessly blend out. And the way that this has been done is with the split line tool. I refer to these kind of intersections as frownies and smileys, depending on which way the fillet is terminating. The frowny typically removes material, the smiley adds material to the model, and the blend is kind of just right. And that is done with the split line technique. I'm isolating these tapered fillets and replacing them with blend geometry. And the compare contrast is pretty obvious. Here we see all the different reflections and edges. I can exactly see where these fillets are, even though I don't have the model edges on. But with the blend, I'm able to create a much more harmonious intersection between those different faces. The last example I'd like to touch on filleting before we get into blending is looking at fillet washouts. A fillet washout is a situation where I have an edge that starts non-tangent and ends tangent. So in this example, I have angle between these faces at the top of this part. There is no angle between these faces at the bottom of the part. How do I go about adding fillet to the model? Well, I have a couple different ways I can go about doing this. And we'll jump up in this example. So I want to cover a couple different techniques. The first being, I might just be able to apply a standard radius fillet. Yep, this actually applies. At 50, it applies. I would like it actually at 25 for this example. Or perhaps it was 30. Yeah, the 30 doesn't want to add for whatever reason. So I can go small, I can go big. I don't quite know why 30 won't add to the model, but we probably have a hypothesis of how to solve this. And that being, we can split the model. So here I'm actually splitting the model, and now I can add my 30 millimeter radius. We can see the preview, so if I unsuppress this, it should build. And even then, this edge has actually still been indicated as tangent. So when I combine these bodies back together with my split, it's actually just kind of blown that away, and my fillet was ending because the angle between these faces was so small. If I'm ever curious of what an angle between two faces is, I can use the deviation analysis tool, and I can pick an edge or I can pick chains of edges, and this will actually tell me what the angle is between this. So I actually see the max deviation of this is 0.45 degrees. SOLIDWORKS treats anything under 1 degree as tangent. So if I were to roll up before this example and do my deviation analysis again, I can see the angle starts at 26 between these faces and tapers all the way to 0. So this is fine for just adding a fillet to the model, but if we were to turn off the model edges, I can once again see that tapering fillet. It almost looks triangular. I'd like to have a slightly different look to this. And this technique is valid for a range of different fillet exercises, but it's not the most stable. Use it higher up at the tree or in your parent parts in a master model environment. And that is the pipe fillet or swept fillet technique. So the fillet is going to give me 2 new edges once I've applied it to the model, and I can create those edges manually. So in this example, I've created a 20 millimeter radius, 20 millimeter diameter circle, and I'm going to sweep that along the fillet edge. I do a little bit of cleanup here with a quick move face and a cut to ensure that this surface is fully tangent with these edges. And then I'm going to do a Boolean subtract or a combine. So this is the same as adding bodies together. I pick a main body, I subtract a second body. This gets me 2 new model edges, and this is kind of looking like an upside down fillet at this point. I can use delete face to remove those faces from the model, and I can bridge the transition with either loft, boundary surface, or surface fill. Boundary surface is great when you want to create 4-sided transitions. Surface fill for any transition that's not 4-sided. In this example, I do need to tell the boundary surface to be tangent to my 2 new edges, but I don't actually need this last edge to be made tangent because these profiles inherently tangentially end. Actually adding the tangent condition here can lower the quality of the surface. I have a couple ways of sculpting this surface, even though I don't have a arc or a transition or something here. I can use the tangent influence slider, and what this does is kind of pump up the surface almost like you were inflating it from behind by giving more preference to the shape of these pink faces rather than what would have been the shape of this face if I had picked a direction here. I can also tweak this little slider here called tangent length, and the higher the tangent length, the sharper this fillet is going to look. So when they're both set to 1.4, I have a much more peaked surface versus back down at 1, which is the default. And I can even go below 1, but I find that values below 1 don't look very good. And in reality, I've never really had a use for tangent lengths below 1. So now that I do have this fillet washout completed, I can knit this surface into the model, and then I cap the end with a surface fill. And once again, this has the merge and create solid options checked to be able to go back into the solid environment. So running back through, I can't add the fillet, split, new faces, fillets end exactly where I want them when I have them split out of the model. Deviation analysis, a great little tool for looking at the difference in angle between faces. We do have this technique of the swept fillet or the pipe fillet where we're creating a sweep and then using this sweep to create new edges on the model. This works in the surface environment too. This could have been a swept surface with a trim to be able to trim out the portion. Just because I was in the solid environment, I had to do it a little bit more of a workaround with the combine subtract. And finally, using boundary surface to create the end of these fillets. And then a hybrid of this technique is I might be able to get 95% of my fillet, but I don't get the very end of these fillet washouts. And so I can just do a scenario where I use the fillet tool to model as much of the fillet as possible, end that fillet early with split, and then use boundary surface or surface fill to be able to end that washout. Go back in PowerPoint. So I want to jump into more of a hybrid solution here. This is a scenario where we have a couple different quality or versions of the same blend. And in this part, we're going to be looking at this particular corner, and we'll jump in SOLIDWORKS, where we have a chamfer that has 2 fillets applied to it, and then it's running into a large fillet radius with some angle geometry as well. So let's jump into SOLIDWORKS, open up this example file, and run through a couple of the different permutations of what this could look like. So before we've added any fillets or doing any blending, this is where I ended up. This was mostly a solid model approach to this point. There was a little bit of surface modeling just to get some of this stuff at the front, but you could get here entirely with the solid tools. And if I only employ the solid tools to try and get me out of this blend, I can get to a pretty good fidelity resolution, but for a higher fidelity blend that the industrial design intent called for, I did have to jump into surface tools. So let's take a look at the first option. And when I showed this to the team at Cortex, the design engineers were like, oh yeah, that was simple. The industrial designers were like, no good. And so we look at the first iteration. I'm applying these 2 fillets to the chamfer edges, pretty straightforward. And then I have a small radius here. It runs down. It doesn't look kind of great. This very much, I can clearly see the features in CAD that was used to create this transition, and it's not at all what we were looking at from a design perspective. So the second option, maybe if we applied our fillets in a slightly different order, we might get a better result. And what we've done here is just tweak the order that the fillets have been applied in, and actually added a slightly newer fillet of like, well, maybe we want to actually blend this edge out here. I'm going to try and blend this flat chamfer into this curved fillet face. And I now have a new transition surface, a slightly different set of edges. And when I go to add this fillet, I once again kind of get that taper effect that we had seen in the previous examples. And I also get this taper effect here. I can see this fillet starting to do some weird things as SOLIDWORKS tries to apply it onto this edge. The software is doing a great job. It's figuring out how to taper this and extend different faces to be able to add this fillet. And note in this example, I was unable to add both of these at the same time. This is a situation where the top fillet needed this little fillet face to figure out a way of ending itself. So I don't actually get a preview there. So another little example of successfully adding fillets. Sometimes, even though they're the same radius, doing them one at a time, this little bit here was enough for it to figure out how this should get applied to the model. And then the final bit that would come in would be that tight radius. Not great, but it's there. Continuing along, I have a slightly better transition by using the variable fillet on this, and I was able to control what this fillet looked like at both the start and the stop. So I had 10 millimeters versus 1 millimeter here, and I can adjust this. This basically controls how much this little surface kicks up. And I found that a result at 1 millimeter kind of kept this edge straight. It worked a little bit better in this example. And so this was just something that I worked through. I tried a couple different iterations of how to potentially get this blend right. And this blend is looking better, but the primary issue is that this fillet tapers rather than wanting to get larger. And I might have been able to put a variable radius or something on the end, but it wasn't really working. And so the technique that I did employ, the final technique, was using that delete face option to clean things up. So this is the exact same fillet sequence. I have this fillet. I have my edge fillet. I have my little fillet here, which actually did help me with this radius. It started to look a little bit better. So I'm getting there. I'm almost there, but it still looks like fillets stacked on top of each other rather than a more seamless transition. And the way that I cleaned this up was using the split line. And if we examine this sketch, I'm just framing out that portion for the blend, and I have this new spline transition here, but I am beholden to my existing model edges. Like I have to make this spline tangent to this model edge. I can't just kind of start it up here or have it bridge around here. So the inputs of what I'm starting with define what I can and can't do with this delete face patch. And I get asked, how do you know where to put these patches? Well, we've got light again, okay. Hope everyone can still see. It's just experience. It's connecting different things and trying different combinations of model edges of what looks good. And the lucky thing is you can just go in and move and say, maybe this needed to be a little bit bigger, so I wanted to start this line. Oh, we're fully in the dark now. It's probably better to see the screen, right? Okay. Well, I'm glad that we could all sit in the dark together on this fine Wednesday morning. It might be a situation where I'm moving this a little bit further back to give a little bit more area for the blend to work. You can experiment with these things and find what looks nice. You tried. And then the final option I would like to go over here is the fully manual option of employing surface features to get a couple different results, and we'll run through these. This is a situation where the split tool was great. So this was my splitting sketch. I'm using this to isolate this little corner of the model, and I got most of my fillets. I don't need to manually model these fillets with a sweep technique or whatever have you. I want to use the fillet tool, but I want to manually just control this intersection. And so now I need to add more model edges to help frame out this blend. So I'm using the split line here. I'm using a split line here. And I'm going to run into a problem with my final split line. And that being the transition I would like to sketch with this spline actually runs over onto this face and to this face here. So if I used to split it, I would still have this little sliver. These edges would not be continuous, and I wouldn't be able to create a nice looking blend. So how do I go about adding a little bit more material to my model? Well, I could start a sketch on this face here and extrude it into the model. It happens to be planar in this instance, but a lot of the time these surfaces aren't planar. I can't go about it that way. So a workaround is, I know I'm going to have to delete the faces anyways to be able to add surface fill, and so I can use surface extend, just make that face a little bit longer. I just pick the edge, I set an arbitrary distance that's longer than the amount of material I need to add, and now when I add that split line, I don't have to worry about the face. I'm able to better sculpt and control exactly what this looks like. I can trim that out with a delete face. And I got most of the way there with a single surface fill. I think this just goes to show the power of surface fill when you're properly sculpting what these transitions look like. This has just been set to tangent, but I have a scenario now where the flat face is starting to kind of blend out. This tight radius fillet starts getting bigger, and then this fillet starts kind of seamlessly blending up into this edge. This is looking pretty good, and ultimately this I think was the level of solution that we went to for prototyping. We weren't molding these parts yet, they were being CNC machined for some field trials, and I know that they were going to get hand sanded and painted, so this level of fidelity was fine for a textured part. I wasn't tooling the solution yet. If I had gone to tooling, I probably would have gone back and resculpted this area. We're starting with the exact same area for my blend, and I'll turn on model edges. But using a boundary surface to help guide this surface. That surface fill is great, but it doesn't give me much control over what it looks like in the middle. It only gives me control over the edges. I can set an edges contact or tangent. So going back through this example, I'm going to blend from this edge into this edge, and by default, the surface or the boundary is larger than I want it to be, but I can grab these little connectors, I can pull them back, I can change my tangency, I can change my tangency length, perhaps I wouldn't want to explore 1.2 on these, so I can sculpt what this transition is looking like. And the reason I'm starting with this is I need to take this flat planar face and get it to transition into a radiused face. So this is helping kind of form the basis for my blend, the basis for the flow. I can knit this into the model. And then because this transition is four-sided, I'm using a boundary surface to kind of blend from here to here. I have tangency on all edges. And then to finalize the transition, I do have to use surface fill because this is a five-sided or six-sided patch. And surface fill is used to help blend this fillet into this fillet, but I'm controlling the transition a little bit more with this initial boundary surface. And if we were to turn off our edges, this gives me a really nice looking transition between the chamfer into this fillet. Note that I only used G1 style or tangent fillets on this example. They're not necessarily bad. This is a very utilitarian product used by law enforcement. We wanted to have that look that it was a little bit more kind of intentional, a little bit more of a institutional style product rather than a very sculpted, smooth, seamless consumer electronic. And that was a decision that the design team made to be able to have this product look a little bit more hard-edged with its radii. And ultimately, this transition was exactly what I was looking for, but I did have to sculpt the final corner with the surface tools rather than rely on the fillet tool to get me what I needed. So running through the examples, this is the problematic corner. I can successfully apply fillets, but I need to kind of create this blend area. I'm doing that by splitting out the corner with the combine tool, the split tool, putting it back together with combine, isolating what that blend section looks like. If I do need to get that high fidelity, I can use surface extend to extend existing model edges. The surface fill gets me most of the way there, and then the most polished example is boundary surface to be able to complete that transition. Final example I would like to get through today. I think we've got 1 more minute, so I'll be pretty quick. I hope everyone doesn't mind bearing with me. Sorry you're late for lunch. Is this G3 blend example. I've got a ID shape where I have this kind of slot shape, and then I have this circle shape at the top, and I need to seamlessly blend them, and I want it to all be G3, like this very nice pebble-looking shape. How am I going to go about modeling it? Well, before we jump into SOLIDWORKS, I want to illustrate one point. And that, I need to edit my slide here, that's a typo, not draft, tooling actions. This is an example where I sketched a slot, but a slot has an arc at the top, constant radii. So what I've done is come in and created a little bit of a blend here, or a little split, and now I'm creating a new style spline with the G3 torsion relation between my arc section and my straight section to be able to help blend this out seamlessly. So if I had just approached this with the slot shape, I wouldn't have actually been able to get that perfect G3. I have to go in and manually correct the intersection. If this was a straight circle, no problem, but these arcs, they really throw people for loops, and I think this is the number one thing I see overlooked when trying to do this style of modeling with these kind of shapes, is not blending between arcs and lines to be able to get that seamless curvature. So opening up this example, the way I did go about creating this is this initial layout. We'll turn off perspective. These are my arcs. I'm doing this at each level, so I'm not trying to do this all in the same sketch, so I convert into my next sketch to be able to define these splits. And I'm also not putting the G3 in this one. I found it just works a little bit better if we split everything out. The challenge with doing this, it's in this sketch, this style of modeling is that, for better or worse, I used to have a technique where I could set all of these control segments to be equal. When adding the G3 relation, it overdefines itself for no reason. I have another video from 2018 that shows how you can manually create G3 between a spline and an arc. It's a little bit more stable. So in this situation, I'm not defining this, but it means any kind of model edits that I make, say I want to make the part 20 millimeters longer, these blue points are staying exactly where they're at. The equals was a nice little workaround of getting that, but for better or worse, it didn't work in this example. But I do have that nice, smooth, seamless transition, and I can go about creating the pillow shape component of this model. We'll roll a little bit higher in the tree. So I have my planar surface I'm creating here, but before we get into the final blend, we'll look at this pillow shape. So the pillow shape is created with two sketches, but it's actually being defined by a single sketch, even though they're on different planes. So here I have a style spline. I was talking about those three different control segments required. So I do have three control segments. They've been made collinear to this model edge, and I have that smooth, seamless acceleration of the G3 curve. Now if I wanted to, I could better define this last profile with an angle, and that would actually make this entire sketch fully defined. But we'll just continue on without it for now. I need to get this sketch here over here. We'll hide this for a second. How do I go about doing that? It's a little buried feature, but it does exist, called derive sketch. So if I pick this sketch, I pick the plane I want to derive the sketch onto, and I go insert derive sketch. I now get a copy of this, and I can't actually tweak the points. I can just kind of move it around to make it coincident. But it is being driven by this original sketch, even though they're the same. So for these kind of blends where you're going from one profile here to another profile 90 degrees, and you want to have that blend look consistent, the derived sketch is a great way about going about it. So boundary surface is being used here. This is a nice little technique for actually framing these out, which is the thin feature. The thin feature is just being used to get new model edges. Mirroring, deleting, and then we'll look at the final blend of today's presentation, and that being the top blend. So I need to re-show the display face. This had to be created as a boundary surface. It's almost a revolve, but it's not quite. It's a revolve on the top half, but it's technically not because it's hitting this blend surface here. So I can't actually revolve it. Boundary surface does a great job. But I'm now framing out this larger five-sided transition. I have another G3 style spline here that's been made with the collinear trick to control this blend. And I'm now purposely framing out this five-sided area for the surface fill to work. And surface fill gets us out of so many of these blending challenges but the inputs matter so much. If I didn't have high quality G3 inputs on this existing geometry, I wouldn't get a G3 style connection on this blend. And so I used the surface fill, I'm setting contact, and this is a little bit unintuitive, but even though I wanted that curvature or higher connection, I found that with surface fill, tangent is more than enough if the surrounding geometry is already G3, and I can use some of the evaluation tools to see how seamlessly my geometry is flowing into each other. Zebra stripes is a great way of evaluating the transition, of cranking this up, and I can see that I have these very smooth flow of light lines from this radius. It blends seamlessly out into these other model edges, and ultimately I was able to create this very smooth flowing geometry where I have very simple shapes, but the geometry between those simple shapes isn't so simple. And the fillet tool, I wouldn't have been able to get to a solution, but using some of the techniques of manually sketching splines, creating surfaces, and then blending between them gets the final geometry that I was looking for. So very much appreciate everyone bearing with me today. I hope you enjoyed today's session, the completed blend. Thank you very much. Apologies for going a little bit over. Thank you for bearing with me, and I hope you have a great end to your SOLIDWORKS 2023.